Hi there. In this video, we will talk about why birds that land and stand on electrical power lines do not get a shock or electrocuted. So firstly, let's have a little background on electrical circuits because it plays a role in understanding why that happens. So firstly, for electricity, it needs a complete path. And when we say electrical circuits, it kind of, you can visualize it in a way that the current flows in a circular path, starting from a simple example. Let's say we have a battery. This is our power supply. In order for current to flow, there is something called a voltage difference or a difference in voltage. And what that basically is, it's the difference between the positive side of the battery and the negative side. So this point in the electrical circuit, let's say it has a specific voltage, and the difference would be through the negative side. So if there is no potential difference, current will not flow. So let's assume this wire got cut off. And so if this got cut off, there would be no current to flow because there wouldn't be a path for the voltage difference from the positive and the negative to occur. Whereas if the circuit is completed and there's no obstruction, we will get a voltage difference, and that will allow current to flow. So if we see our bird example, let's say a bird stands on a pole. Now this pole, uh, it has a specific voltage difference, and in order for the voltage difference to occur, just like we saw in another example, and where current flows, it needs another path so that the current can flow. So let's say this is two phases, for example. Let's say this is a live and a neutral phase, okay? So let's say if there's a wire going from here to here, then we will have a path. But right now the bird is only on the wire, on this wire, and this wire is waiting for a path to complete. So when it sits on the power line, both of its feet are at the same voltage or same potential. So you can visualize it in a way where the bird kind of, let's say, touches this wire, but this wire is disconnected. So there's no path for the current to flow. So when would be a case where the bird gets electrocuted? Let's go and see another example. So in the same example, because the bird is on the same wire, there's no voltage difference because both feet are on the same line, so it will not get electrocuted. But let's assume we have a two-wire system, and let's say the bird landed on this wire, but its body is touching a wire from a different phase. So we have two phases here, and both of them have uh, two potential differences. That's what happened now. So there will be a current flow because a voltage difference exists. And as a result, the voltage difference will, in electrical power, what we call that is a line to line voltage. A line to line voltage is a voltage difference, and the result, it will cause a current to flow through the bird because there is a path, and as a result, the bird will get an electrical shock. So let's say another example. Let's go back to our single pole or single wire example. Let's say the bird is still standing on that wire with both of its feet, but somehow there was a connection between the wire and, let's say, the wooden pole. So now we have another path, either the wooden pole or the ground. So maybe let's say a tree at an instant it fell, and it caused a path to happen for the current from the electrical wire to the ground. So in that instant, a voltage difference occurs, and instantly there will be a current that will flow through the bird. So in that instant, yes, there will be a shock because there is a voltage difference, and the current will flow from the bird to the ground, and that's where the shock will happen. So in real world examples, we typically see birds, especially migrating birds, they land on these wires and these distribution and transmission lines. And that's okay. They can safely land on them so long as they're not touching, their body is not touching two wires at the same time. Now, normally, there's a significant distance between these wires, and the birds are relatively small, so they're not gonna touch. They're not gonna cause uh, their wings and body to touch two wires at the same time. And that's the case for most transmission lines and distribution lines. The wire spacing is more than large enough to accommodate the birds, where the birds can safely land on these wires, and they will not there will be little chance for the bird uh, to touch both wires at the same time. So to conclude, in order for a bird to get electrocuted from these electrical transmission lines and distribution lines, there needs to be a voltage difference that would occur. And since the bird is standing on one wire, so one wire is the same voltage across the whole wire, so there is no voltage difference, and as a result there's no current, and if there's no current there will be no electrical shock, and hence that's why birds can safely land on any electrical wires and distribution lines, unless, as we've seen, there somehow a path occurs where, let's say, a tree suddenly lands on the same wire that the bird is standing on, and this is a very rare occurrence that would happen. Maybe these would have occurred during extreme weather events or disasters, but when designing electrical transmission lines, these are rarely taken into consideration. So one takeaway from this video is, if it's the same voltage and there is no voltage difference, then no path would occur, and as a result there would be no electrical shock. Thank you for watching this video. Please like, share, and subscribe for more videos on electrical engineering and power systems.